Good afternoon, everyone. My name is Renato. I am from SKF Sweden now. I've been working in Sweden for 1 year now as a responsible of advanced analytics and visualization on the product development side. Actually, 1 year in Sweden, but I have been working for SKF for 11 years now. So I'm actually from Brazil. Before anyone asks, the weather in Sweden is really good, right? Oh, sorry. So I will be talking about a project that we have at SKF right now on how to automate the problem detection of rotating assets, but by trying to use what we call infrequent data or infrequent measurements. I'm going to frame the problem. So talking about SKF, really quick. The vision for SKF that we have right now, we want to provide the world reliable rotation. We are talking today a lot of times about servitization, how to offer services, etc. And well, we are doing this for some time now. We have some cases like in Latin America where we are providing services. I mean, the bearing as a service for customers for 15 years already. So we really believe that the right thing to do is to provide not just the bearings for the customer, but the rotation. We believe that if the customer has a reliable rotation, he will be more competitive in the market. So some numbers about SKF. We are more than 100 years old. We have more. Right now, these figures are from 2016. So we have more than 50,000 employees around the world right now. It's a huge company. I mean, and by being a huge company with huge challenges as well. So let me start framing the reason for what we decided to run this project right now. We have two value propositions. The first value proposition that we have is what we call the rotating equipment performance. So as I said, I want to offer my customer, I want to make my customers run his assets with a trouble-free operation along the life of the asset, along the life of the bearing. And also, we have the product value proposition, where I want to be able to deliver value over the whole life cycle of the bearing. If we take the rotating equipment performance, one of the most important parts of offering rotating equipment performance is actually the condition monitoring of the asset, right? So if I may summarize in a really simplified way, that's what we consider the process to make the condition monitoring in an asset. So first, we have the data acquisition part, so where I have the vibration, for example, of the equipment. I am collecting this data, I'm acquiring this data by using two different ways. Let's say that I have products with two different reasons right now. We have what we call the offline vibration monitoring, and we have what we call the online vibration monitoring, right? I'm going to explain later why do I have that square in there. So I'm collecting this data using one of these ways. I'm sending this data for the cloud, for example, and then I'm going to the second step. That's what we call the data analysis. In the data analysis part, I'd like to divide this in 3 different stages as well. The first thing, not considering the machine, but considering the human being right now, I need to first detect the problem, right? So I am an analyst sitting in front of a computer receiving some vibration data from one equipment. I need to analyze that. So I'm going to receive this data. First thing that I need to decide, do I have a problem or not? So this is what we call the problem detection phase. The second stage, it's what I call diagnostics, right? So, okay, I have a problem. But what is the problem that I have in this asset right now? So I need to say, I have a problem and I have a bearing problem. I have a fault in the outer race of the bearing, for example. And after I detected the problem, I did the diagnostics. Now I need to define what is the remaining useful life of this asset. All the customers are requesting this right now. So I need to say, okay, the remaining useful life is 2 weeks. You need to replace this bearing in the next 2 weeks, for example. After I did that, I'm going to send these results for what I call the data visualization reporting and then I need to do the corrective action. Well, considering this condition monitoring process, one of the goals of the project is I want to try to automatize this stage. So is it possible to create an anomaly detection algorithm to help me doing this part? Because if I'm able to do this, I might be able to be much more efficient than I am today, right? And also framing this project, I want to do that right now just for offline data collection, just for this infrequent measurements data collection. Why am I doing that? Well, in the end of the day, SKF is monitoring more than 1 million assets all over the world, right? Okay, there is a market trend that customers will start using more and more wireless sensors. They will start using more and more continuous monitoring of online data data acquisition. But guys, real life, just 10% of these assets are monitored by using online data collection right now. All the rest are monitored by using a person going to the asset and collecting this data using a handheld. I have no problem detection algorithm for this type of data right now. Not by using machine learning. I have some other types, but not by using machine learning. And I really believe that if we use machine learning to do that, we'll have much better numbers than we have today. So, well, this is the problem that we want to solve. So basically, what he did, I formed a group inside SKF, led by a data scientist in SKF. I took some domain field guys that they are really knowledgeable about the application of the berries, really knowledgeable about the application of the assets. And I also invited Combient, one of our partners, to support us on this challenge. So, well, this is the problem that we want to solve. So I'm going to ask Rerngvit now to present the technical solution.
So thank you so much, Renato, and I'm very happy to be here. So before I dive into the technical detail, how we approach the problem, let me first give you an introduction of what is Combient or who we are as a company. You probably have heard about SKF before, but maybe you haven't heard about Combient. So we are a unique collaboration network of non-competing Swedish and Finnish enterprise of the company that we show here. And SKF is one of our owner. And Combient is totally owned by some of the company in this sphere. And we only work with the company in this sphere. And this company, if you see the overlapping, they are not overlapping at all in any domain because none of them compete. And because of the idea of non-compete, they can share knowledge. We have a mutual NDA across the sphere of the network. So we can share secret and talk about how we operate the business with the vision to drive digital transformation. And this is a key scope of our mission to drive Combient and how we help our partner company in the network. And one of the team within Combient, we specialize in applied data science to transform the business. And the case that we're going to show today is one of the work that we did for SKF. And as Renato mentioned before, it related to how you apply machine learning to investigate the feasibility for this data. Okay, now I have explained to you who we are as a company. Let's now move on to what is the problem we try to achieve in this project. Basically, it's about answering these questions. And which is similar to what Renato said before. It's about how would you, is it feasible at all to use infrequent vibration measurement or the offline data? Many talk today already have articulated how would you use online system. But the infrequent here make it much more challenging. That means you have very infrequent data. The amount of data you have per asset, maybe it's collect once a month because it's quite expensive to send the people to the asset and collect the data. However, it's important since most of the data are in this format. So that's why the algorithms are important to be investigated. Now I explain to you what the problem we try to solve in the overall. Let's move on to what kind of data that we have to give you a feeling of what the vibration data, what it means. This is the microlog analyzer, the device that use to collect the data, you connect the sensor, and you collect the vibration over a certain period of time. And this is how the data look like. The horizontal axis represents the time, and the vertical axis represents the acceleration signal of the vibrations. Then this is when you have one single sample, it looks like this. But in order to extract the feature to build a model, one possible way, or one way to extract the feature is you take the peak-to-peak signal. So this way you could quantify or summarize this waveform into a single number. There are many different approaches, as some of the talk mentioned today. You could also do Fourier transform and look at the frequency domain and capture certain type of frequency as well. That's a different angle. How would you extract the features? Okay, now I have shown you how the data look like. Let's now move to give a little bit into why this problem is difficult. What are the key challenges? The first challenge is about the amount of data. So although the data set that we obtain are at reasonable size, about 30,000 assets or heavy machinery and about 1 terabyte of size. However, the amount of data per asset is rather small. Let me elaborate with this figure here. On the horizontal axis represent the number of level sample. That means you have the vibration data that I showed to you before, and the level by the human analyst that say, okay, there's a problem or there's not a problem in this case. But the number of assets that have this data, you grow down very quickly in the log scale. So if you talk about like 50 sample, that would be go down to just 1,500 assets very quickly. That means most of the case, you do not have so much data at all. Most of the case, maybe you have 50 to 50 sample at best per asset. And then you're not going to try neural network here because it's going to overfit like hell. So you need to be a little bit careful and go a little bit more simpler model. How would you engineer the feature and approach this problem? Okay, let's now move on to the second challenges, not just the limited amount of data. It's also about the nature of the data itself. Because when we talk about heavy asset, you take the vibration measurements, it's not a single location. It's actually multiple location. For each asset, you actually have multiple measurement points. Here you have 6 measurement points. So each time you have about 6 these waveforms. However, since this is based on human, sometimes you have human error. So human not always collect 6 of them. Sometimes you have missing, like sometimes you have this one gone from the data, sometimes this one gone as well. And not just that, the level that you get, it could based on this decision, this waveform, or it could based on these 2, or could based on that 3, but it's not in the data of what waveform that actually based on. The decision are not recorded in the data. So these are the challenges. And this figure here just illustrates that you have variety kind of asset with different number of measurement points. Okay, these are the 2 key challenges. The last key challenges is also similar to the lift case in Connie that mentioned before. We also have variety type of asset type. In terms of like the vibrations, you could have a pump, you could have a fan, you could have a motor, and each of them also have different vibration signature. Even if the same type, but if you operate under different conditions, the vibration also not the same. And it's not the same when you determine whether there is a problem or not. So these multiply into the total of why this problem is complex. Okay, so I have explained to you the key challenges for this problem. Let me move on to how we decide to approach this problem, which also based on the challenges that we outlined so far. We decide to approach it in 2 different angles. The first angle is that we consider a single asset, which means we train and test the model on the same asset based on the time. So you take data from the first time and test the model on the second time, later on in time. The disadvantage here is that you have very limited amount of data, like 50 samples per machine that I mentioned to you before. And also, in order to use it practically, you need some training period, which make it the model would not be so useful since you have to wait until the training is ready. Another angle we investigate is we try to build a general model for vibration signature. So we try to combine multiple assets by employing a certain heuristic so that we can filter and group certain assets together. And we train on the subset of the asset and test on another subset that are completely not seen before. And here, as mentioned before, you're going to have the mixing of different asset type and certain like complexity that come together with that. Okay, so I have explained to you the approach that we decide to use based on the challenges I mentioned to you. Next, I will explain to you what are the outcomes that we got, and mainly based on the test data that the model haven't seen before. Okay, then these are the results for the multiple asset model with the precision and recall curve. And these are the definition of the precision and recall. Hopefully, many of you are probably familiar with them already. And we formulate in terms of a classification problem. And the blue one represents the model performance. The red one represents a baseline of flipping a coin. And this area here is mean when we do multiple random sampling of the asset IDs. So, and we visualize the standard error to give you a feeling if you are lucky sometime, you get certain asset and get another asset. What would be the variation of the model performance under this condition? And from this result, we also observe that similarly, even though we go into a different direction, we end up with quite similar result to the single asset model. I would like to give a feeling here that this is the 4 weeks of work that we show that there is some signal in the data that you can somehow do automate this process. So if we come back to the project goal, is it feasible? The answer would say yes, it is. But the current model performance today is not something that you would put in production. It would require some more work to push this one to the top right corner. And this is ongoing work that we're going to continue on the project together with SKF. And another important thing is that because of the learning that we have so far, we also feedback this knowledge about how would we do better in terms of software development in order to improve data collections. Because we now know what data would be good to have that we don't have before. And this is the learning and iterative process that you do a quick project, you pivot. And this is the approach that we decide to take. Okay, now I have explained to you the technical part of the project. Let's now move a little bit into the way that we work at Combient in terms of the analytics team, which for myself as a data scientist, I find it very interesting. As we mentioned before, we have many different companies in different verticals. Could be ball bearing company, healthcare, telecommunication, financial organization, many different companies. You can jump between different domain to the next one. And we have many different data scientists that work on different projects. As it turned out, many companies actually have many very similar problem domain. For example, this project here would be predictive maintenance, but Husqvarna also have heavy asset, also have predictive maintenance. Electrolux also have asset. And the individual and the knowledge and the data that the person go there to work with come back to Combient. And then we share the knowledge so that eventually it would be more better business value back to the whole owner company as a group, because we can share knowledge as if we work in the same network. And this is the key idea. And the same with churn prediction. If you have subscription like SEB, or if you have subscription like Fortum, you also have churn prediction. And you can work together to learn the way how you build churn prediction model. And eventually, this would lead to the higher business value to all the company within the sphere. Okay, so I have shown you why I think this way of working is interesting and how the company can learn from each other to drive better prediction and better model. At the end of the day, it's not about who have the better algorithm, but rather who have the better data. This is what we believe in. My last slide is the shameless advertisement. So we are actively recruiting for people. We're looking for talented people who want to solve complex problems in order to drive innovation using data science area. So if you want to take up the challenge, welcome and join us to transform the industry together. Thank you a lot.